Question 13 says calculate the perimeter, that's the distance around the outside of this regular hexagon. Well, we're told the regular hexagon has, well, I'll call it loosely a diameter of 10 centimeters. But the great thing about a regular hexagon, of course, is it's made up of equilateral triangles. So let's have a look at this. So that means that we're going to have a distance across here of also 10 centimeters. And we're going, oh, sorry, you can't see that. And we're going to have a distance across here also of 10 centimeters. Here we go, 10 centimeters. So each of those is an equilateral triangle. And if it's 10 all the way across, then each of these is going to be 5. And of course, if each of those is 5, then each of these parts around the outside is going to be 5. How many bits around the outside we got? Well, we've got this bit that's 5, this bit that's 5, this bit's that 5, this bit that's 5, this bit that's 5, and this bit that's 5. And 5 times 6 is 30. So we've got 5 times 6 equals 30 centimeters. And that is the answer. So the perimeter, and they should have a gap in between here, it should be 30 space centimeters. That was rather clumsy of me. In fact, I'll fix it right now, actually. Here we go. Let's make that 30 centimeters properly. 30 space centimeters. There it is. Okay, 14. We'll do 14 at the same time. The diagram shows a square, a circle, and a regular hexagon. Circle touches the side of each square and the circle, blah, 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 blah. And the area, right? I do love these. Regular hexagon. Here it is. It's going all the way across the diameter. It touches the circumference here and touches the circumference here. Of course, the square also touches the circumference here and here. So whatever the distance across here is, or here is, or here is, these are effectively all diameters. And of course, the distance, therefore, across from the bottom here to here is also a diameter. It just happens not to go from one corner to another, but it's still a diameter because they all touch the edge of the circle. Now we're told the area of the square is 16, and a square must be something squared equals 16. So we're going to call each side x. In other words, x squared is equal to 16. So if I want to find what x is, I can just find the square root of both sides, and the square root of a square means that x will equal, now of course in mathematics we must say it's plus or minus 16, which is 16, so x would equal plus or minus 4. But of course it can't be negative 4 because it's a distance. You can have a negative direction, but you can't have a negative distance, so the answer must be plus 4 only. So there it is, it's plus 4. So each of these sides must be 4. Now it says the area, what's the perimeter of the hexagon? Well, the perimeter of the hexagon, therefore, must be, if we've got a sides of 4, 4, and 4, then this must be the diameter across here, must be 4. Because the diameter is here as well. This side here represents a diameter. Now, if that's 4 across there, then each of these bits in here is 2 and 2, and 2 and 2. And the sides are also 2 and 2, because they're all equilateral triangles. Here we are. So everything's a 2. So the sides are 2, 4, 6, 8, 10, 12. So the sides are 6 lots of 2, which is going to be 12 space centimeters. So the perimeter of the hexagon is equal to 12 centimeters. And that's how we find our answer.